Bonjour, je suis heureux d'être ici. Je do this session in l'anglais, and from now on I'll stop butchering the French language. So you'd be very, very happy about that. So I'm working in this game, right? Working in this game. This is the trailer that'll be going there, so you see it. And you know what? Games are hard. The games are really hard. There's all these systems going around for them to do what you want them to do. And I've been thinking about, okay, so there's a 2D side scroller beat 'em up, so a lot of combat going on. AI for the NPCs. The AI is not that smart, but you still need behavior trees or system for animations. So we're talking about complexity, and we're talking about how to handle that complexity. And I'm sure, I don't know what your background is. I'm going to assume everybody codes every day. Yes, raise hands. Okay. When it's just, I don't want to put off people. So complexity and how to handle it. So when, about a year and a half ago or so, I started reading a lot and seeing a lot on how, with functional programming, you can tackle that a little bit. You can make it easier to handle. I started looking at it. So I'm going to just stop this and go into the actual presentation. It's a beautiful game, you can say it. I know you are all mesmerized by the beauty of this game. Look at this. Look at that boss there. Oh, yeah, all that particles. Brutal, literally. So it's coming to Steam in 2 weeks or 3 weeks. So you are all going to go and put it on your wish list, and then you're going to buy it immediately after. Or I'll chase you somehow. I probably won't do that. We're going to see code in a little while, but I'm going to give you some background. So I was telling you, functional programming, particularly with F#. And who of you does C#? Great. So this talk is all for you. So complexity, how you handle it, right? So these solutions that we were talking about were elegant and beautiful. You could see Haskell written, and you could read it and kind of go like, wow, this is really simple. A tree in 3 lines of code, like a tree, actually rendering like some sort of text with the tree, with 3 lines of code. I love that, but I can't use it. When I try to go and do something like that in my code, I can't. I also started kind of thinking about Haskell and its types, right? And Haskell knowledge, did you heard of Haskell and what it does? Raise hands? Okay, well, the type system in Haskell is so much more expressive. If you do a C#, the type system we have in C# is the equivalent of a t-shirt when outside it's snowing, okay? It's generally on your way. And it's not because I hate C# or anything like that. I've been doing that for multiple years. But we're just shortchanged. So, as I said, Haskell, you're there. I go and see all these beautiful things. I go try to learn it and use it every day. And what I find, it's hard. I'm fucking scared. I don't care if I can say it fucking or not. But I'm like this poor rabbit / deer. This is the best picture of something in headlights I could find. It was overwhelming and scary. But I was like, okay, I like these ideas. What do I do next? I just started checking out F# because it's the next obvious solution, right? It's on the .NET platform, so you have it on the .NET and Mono. So you have that. It's open source. It's really open source. Like in the last month or so, they got over 100 pull requests from the community for F#4. It's multi-platform, for real. You can use it in any platform you want. Mono Develop, Xamarin Studio, Visual Studio, you'll see it now. The tools really came along big time, so you'll see this. And the reality is, F# is a functional first language. And what that means is that the main thing that you think about when you're thinking about solution is functions. You can pass functions around as parameters. Okay, now I'll give you a second to think about what that means. The thing, like, we can do this in C# already, but it's really, really painful. It's like expression of function, some weird generic stuff. So with F#, it's really natural. You can literally, you can use specific operators to concatenate functions. So you can say, do this, then do that, then do that. If you want, you can use coroutine within the functions aggregations, and it's really, really nice. So you think functions first. The other thing you think about a lot is immutability. And this is where all of you should go like, you are insane. Immutability in a game where you need state all over the shop. So you should be kind of doing this. One of you should do it at least to represent yourselves. There you go, there you go. Whew, I think we're in problems. Okay, so you can actually do it. When there is some very extreme approaches to using functional languages from the game engine up, but I think a more pragmatic approach is to take it at a slightly higher level. I'm using it for scripting, for example. That's one of the many places I use it. But the answer to this question this cat has, he's going, oh no. The real reason for trying this is that the tools we use to make stuff shape us. They shape the way we think. So if we use a bad tool, we're going to do something bad. And I'm going to think that that's the way. On types, right? The type system that I'm talking to you about is kind of like sushi. If I told any of you before you ate sushi, hey, let's eat some raw fish, you'd probably go like, oh God, it's disgusting. But in reality, with the fish or with the types, a more strict type system, you get this amazing sashimi. Oh God, yeah, that's beautiful. So think about sushi and about F#. So yeah, why functional? That's why. So a little tiny bit of history. What you're going to do is you're going to try to guess, and I'm going to query you, quiz you on what do you think that does, right? But so meanwhile, I'll tell you the story, the history of F#. It was originally invented by Don Syme, the same guy that brought you generics, in 2002. Then we got F#2 by 2010, and then F#3 by 2012, which got one of the most amazing features on any language, really, and I'm not overselling it, called type providers. And I'll tell you in a second. And as you can see, if you study the ML, this is from that family of languages. It has some influences from Haskell as well. So kind of that's all the history you need to know. So I'm not gonna point first, but if you don't get all talkative, I'm totally pointing. So who's gonna tell me what the first line of code does? Come on, guess, it's not that hard. Oh yeah? Yes. Well done. What a prize for him. Oh, yeah. Woohoo, yeah. Well done. So the second one, what do you think it does? We're declaring a function. When we take x as a parameter, notice how we don't have any type. The compiler will infer the type, and you multiply x by x. By default, the compiler, on the first use, will try to define what kind of thing it is. So if I pass an int, it will get it as an int. If I pass a float, it will get it as a float. That will be only when you, in certain scenarios, but that's the default behavior. So it's caveats. I'm not selling the whole truth, but it's close to the truth. So in here, we're saying SQ, we're binding let SQ the square of 42. Notice how this is supposed to be a value, and this is supposed to be a function, and they are both defined the same way. Right? And if you think about it, the correct way to think about that is that you're binding to an expression, okay? And an expression is basically anything that returns a value. And I'll let you chew on that for a little while. So in practice, what you're doing is when you need a function that will do something, you do let. When you need a value, this is an immutable value, you'll do the same thing, which is beautiful. So I'm throwing you a whole language, so I know it could be a little bit overwhelming, and that's okay. So that's cool. We have binding, we have function declaration. If we want to do that this is a particular, X is a particular type, what we're going to do is colon, like X inside parentheses, colon, and the type. And we can also define the type of returning. What does the function return? What type? Anybody totally lost so far? Or are we all here, having fun? Yeah, cool. So here, we need to declare types. Let's say you want to have a type to represent a vector. Okay, you have that image in your brain? Like the burns that you have to type 1,000,000 keys to do this? Now imagine, right? Imagine if a language could make it so that you have, say here we call it vector 2D, and we have X, int, semicolon, Y, length, whatever else you need. And that's it. Imagine all the typing you don't have to do. Oh my God. I mean, you should all be really excited by now. So that's how you declare a type. Now, the next one is really, really interesting. Because you look at it and you kind of think, okay, so obviously the NPC is a character and the player is also a character. But they are actors as well. So how does that work, really? This is what your brain should be doing, just in case we're not on the same page. So this thing is called a discriminated union. What that means is that you put stuff together when it suits. Logically, you think as aggregating types, okay? But don't think about that just for a while. I'm trying to give you high-level theoretical approach versus actually doing stuff, which is what I think we all like to do, okay? So in this case, we can define, I'm gonna sit down, oh yeah. And as you can see here, I'm defining a type, right? John Doe, we say first John, last Doe. So we're using this definition. So this would be of type actor, okay? And then we can say, actually, I want it to be an NPC, John Doe. And we're saying this is a worker. So I'm just showing you how to implement things, which is nice. The good news about all of this is that for those of you in the back, you won't see this because I didn't realize this will be the height. But basically at the bottom is where you can find all this code and more. What I'm going to do is actually show you code. And I'm going to have to drop this. Sorry. Cool. So I'm actually going to show you code, because this is how we do things. First steps. So we have a thing similar to that. F#, not only is really cool, but also you have a REPL. So that means I'm running the code live. It's here. I don't know if everybody can see it. Should I put this up a little bit? If you don't talk, I don't have the crystal ball. So I'm going to, because of your silence, I keep. So here we have these types defined. We have a weapon, a move, and a behavior, right? This is just, think about types as you would is a class in C#. No problem. Just for the moment, it's not, but whatever. So we have this discriminated union here, and we're saying this stuff. We're saying we have a type character that is a player, an NPC, or a scenery. Don't judge me. Because a scenery sometimes is characters. It could be like a deer walking around. It doesn't really do anything, but you don't play with it really either. So here I can define the player saying which row and katana. And this, I'm very unfair on you, because I should have explained here that when I define this player of move star weapon, I'm actually doing this thing, this really smart thing, where you define a tuple, okay? So a tuple is simply an n number of things with a particular order. So the difference between this and what we've seen before with the definition of John Doe and everything was that doesn't need an order. That's about it. So this needs a type, and this needs a type. And the interesting thing is, like, when I execute that in my REPL, I can see the compiler and what it sees. So when I define this, Jiro. Jiro is the character of my game, the one you're going to all buy, remember? Okay, cool. So when you define Jiro as a player, here the REPL is really interesting, and you learn a lot about what you see here, because you say, Jiro is a character, but it's defined as a player who has the throw and katana, which is in respect the move and the weapon, which is the same order this is in. Again, I know that this is too much, but just try to imagine with classes how difficult and how much more code you will have to do just to define this. And I think that's where you start seeing the advantages of using this. So we have our player, we have a tree, and we have a mempo warrior. And also, if you're bored or something, just ask me or give me some sort of sign, like pretend to fall asleep, so I know that it's not cool. And so we have these types. Great. What do you do with the types? I don't know. You use this really cool thing called pattern matching. Does anybody know what pattern matching is? Like anybody wants to like hazard an idea, like guess. Do you match? No? Yes? You match pattern, yes! Another prize for the very, very person that is here. I couldn't find a good actor, sorry. So how do you do this? I define a function here called character, find player, and I pass it a character. In reality, the pattern matching happens here. And I think even if I don't explain it, if I don't go and tell you exactly what's happening, you can kind of guess. You're matching the character. Character has some sort of thing, right? And you're matching it. If it's a player, do stuff. If it's something else, anything else, you say, I didn't find it. It's the difference between a switch case and this is that you can do way more. Because it's like an advanced switch case, because this doesn't have to be a value. This could be an expression. This could be something else that I'll show you right now. But mostly, initially, logically, it's kind of like this. See here the way I say, match with player, move, weapon. You can even add stuff such as when, I don't know, so I can't type I told you I can't type. When move equals monkeys. So you can add more stuff, right? And have special stuff that makes it easier to do things. And also you can give it a value, like you can say, okay, I want to kind of deconstruct what I sent, and I want to have move and weapon. Because remember how when we define the character, the player has these two things. And maybe you want to work with that. Now, this is a trivial example, right? But what if you had something like this as a decision maker of something, and then you say, the player will do this move and has this weapon. So you can kind of tell the animation system, play with this animation and this weapon, and you can then split and say, I want the player to play this move. And again, think about how the flow of the program changes because of this. I know there is a contrived example, but still. So if I do, okay, yeah, I should probably do this. If you do, what did I do? Cool, nice. I'm going to show you how I really can type. Cool. So in here, I have this find player, and it's telling me I have a parameter called character, that is a type character, and returns a unit. And the unit is, it's kind of like the nothing. But nothing in the same way we think of multiplication. It wouldn't be 0. It's more like a type that represents unity. It represents the one thing. This is irrelevant right now for all of you, but it becomes relevant very quickly because it means do nothing, but this is something. I know. I told you. It's your fault. You were all asking me, looking at me, questioning me. Now I told you, and now you don't understand. How is it my fault? So if you run this function that we defined here with 3, I'm going to give a price of an empty glass to who can tell me what will happen when I do that. I know you all want this. yay! So he went now 2 prizes. That's very good. So this is all. I have very, very short time, and I can show you way more after. This is all just basic F#. I'm going to show you one more thing. And this is when it gets really fun. This is actually game code. It's for this amazing game that you know, it's a really difficult game. It's called Breakout. Don't tell anyone just yet. So in here, this is one thing I forgot to tell you, actually. F# not only is functional first, but you can do object orientation and imperative code if you choose to. But the language kind of says, it tries to push you. The easiest thing to do is to do functional code. So you feel kind of dirty and awkward when you don't. So you end up, when you do old-style imperative-y kind of code, you wind up writing something like this, which, if you don't see very well, I'm very sorry. But you can change that. So this is old school, if, then, or-wise, more code. The part that we're going to focus is this if, and then else if. As game developers, we have a very interesting tendency to write a million ifs, but that's not cool. We want to be cool and hip, right? I'm joking. But so in this case, for the keyword, the way this keyword works is that when you have keyboard key press of a key, we're going to say that's left key. When you have a right, it's right key. When we have other key, you just return a string. And in here, with this pattern matching thing that you learned about a few minutes ago, you can match the keyword. The compiler will realize that you're matching the keyword to an active pattern here because this and this is the same type. And it will say, left key. I know about this thing. You know, I'm really sure. So you say, this is how you return a left key, or a right key, or an R key. And when you're matching this, you're able to decide based on that. I know that my voice could just be blah, 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 blah. But I think when you see the code there, it's actually quite obvious, or way more obvious than whatever I can say. And the more interesting thing there, the most interesting thing there is actually that you can do more. Because in this case, you know that you press left key. But what if you want to left, but definitely not right? Because that would be a cheat. Then you can do this other smart thing. Say, I'm going to define, this is called a multi-case active pattern. What if I want to define a single case? And then you can do, I have a great name for things that need to be name changed, like left something. God, what a terrible name. But anyway, in this case, I can define a different pattern match for left something is true. So, okay, left something means that I press the key, left. And right something is, should be actually not true, but you're pressing both in this case. And with that, I can control that both keys are pressed at the same time. And say I was using a controller, I could say this button was pressed for 5 milliseconds. You know, you can start adding to this logic while you're pressing A and B. And after it does that, you send the message, such as rumble the controller. And then after that, you do something else. I hope I'm giving you a glance, because I can't do more. It's just too short the time. So that's some code. And I'm going to tell you in that little bit of time that what we've seen. So we've seen binding. 4-part and 4, I lie about that. I didn't show you that. These two either. Discriminate union, pattern matching, active patterns, and I also didn't show you type providers. I can show you after if you want. But in this very short time, I had to tell you all these ideas, right? But there's way, way more. You have sequences. The asynchronous workflow are amazing. Computational expressions is actually the tools that the developers of the language use to develop the language. So us, as mere mortals, have access to that. Partial application is super simple. Basically, when you call a function with not all of the parameters, and you give it a name, you bind a name to that, you can call that later when you have that value. So you can leave something just ready to go with all the data you need to run that until you're ready. And that is beautiful. And that's also why you don't need inversion of control in this. And this is the cherry on the top. Writing DSLs in F# is really easy. So that's the language. Beautiful. Great. So it also has an amazing ecosystem. How I started using F# in my game is actually using FSCheck, which is a property testing framework. Right? So what you do is you define properties, and the framework generates values. And you test based on that. So you have a few things like score should always be bigger than 0, stuff like that, and should never be negative. And when you increase, it should increase. And suddenly you just cover your whole score component system. And that's very nice. FSU and FOQ, unquote, they are all testing tools that are very function friendly. The more you do F#, the more it becomes easier to use. But then those are testing tools. These tools, Fake is a DSL for make. And you don't have to write this horrible stuff, but you write it in F#. Project Scaffold helps you kind of just have a thing. And Fsharp is in alpha, but basically it helps you generate bindings to C-like C libraries on the fly. And compiler services, you can compile F# on the go. And actually, that's what we use ourselves for scripting. Where do you use this? I actually think I answered that. But this is F# is used a lot in financial applications and statistical data learning, machine learning, stuff like that. And resources, because now we're all convinced that you should learn. If you are in France, or in Paris in particular, there's a really good user group that I met yesterday, and they are in meetup.com. There's a conference next week in London, and they are amazing. But if you're just trying to go and start, try fsharp.org, fsharp.org. The best place to learn about the languages, probably F# for fun and profit, is a really nicely timely thing that explains how all these things that I just throw out really quickly work. Expert F# is a great book, and so is real-world functional programming. And with that, I think I'm actually on time. Thank you so much.
Diamond, thank you. All right, so who has questions? There you go.
So yeah, I have a question about it then. How would Ankira look different? How would the game be different if you weren't using it? So what's the key thing that it has enabled you to do in say the last year that has accelerated what part of the game that now is way better?
Well, the first thing that it gives you is that say you have C# code and you have 200 lines. Suddenly, in 90% of the cases, you have 20, 25. So it starts with conciseness. And it's all because of, I think, the type system and a bunch of smart syntactic sugar things. But the main thing is just shorter. And yeah.
So faster development and more features get in because
yes.
Everything's concise.
And because you write less code, you also have less bugs. Because you can have bugs on code you haven't written. The other good thing is F# doesn't have nulls, or it supports nulls because .NET. But the F# types don't have null, they have unit. So I don't know you, but most of my bugs are null reference exceptions. And suddenly I don't have them. So that's kind of cool. Yeah, there's one down there.
So, sorry, did you say the types they can be null? Is that what you said? Okay, right, sorry.
I know, it's amazing, isn't it?
So you say like F# help you to have like more concise code, but it's not true. Like like conciseness is necessarily a good thing. Like you can make like super concise binary operations that do magical stuff, but it's really hard to understand. And when you want to maintain like a large code bases, it starts to be like a nightmare, basically.
Yeah, but it's not concise at the price of legibility. So it's concise, and it's like that example when I defined the person or the actor, and it was first name, last name. And the wins you get are exactly like that. That's one line of code. When in C# that would be at least 6. And it would be the same in your brain, in all our brains. You read more or less the same thing, but it adds up. You know, oh, I forgot this. It's a different, slightly thing. Oh. So that's how you get the conciseness. There's a bunch of different ways to shorten it up, but also it's functional. So then you have that added thing, like added value. I didn't want to call it like Tesco, whatever. But yeah.
Okay. Cool. Other question. I'm not really sure how relevant is it, but so when you write like C++ code, you have a pretty good idea of like what the compiler is going to generate and how like performance this code will be. How do you do that with F#?
Well, the F# is a .NET language, so I've been doing C# for like a lot of years, nearly 10. I know what it will compile to because of my knowledge of .NET. So if you're trying to do performant F#, what you're going to do as a good developer is build it, decompile it with ILSpy or .peek, look what it's doing, and if you don't like it, you go and change it. There is the things like you need to think about where you're using this. For example, we use it in scripting, so it's high-level stuff where we can allow not necessarily the most performant code. I'm not using it in, I don't know, rendering particles, but I want to.
Okay, thank you.
No worries.
I actually have a question. So I can see the conciseness, but I do a lot of programming in Python, and that's very concise. So what about the functional part of F#? What advantages does that give, and how do you deal with the crazy immutability?
Well, the things like most people that do Python in the machine learning find F# like they feel quite at home because they are similar-ish languages in that white space stuff, whatever. But this is not your question. Your question is about functional. I think because I've been using it for like F# for about a year now, I'm used to and don't run into problems because it has a very nice learning curve. So you just deal with it. The advantages you get is that because you have less state that changes, you have less side effects, you have pure functions, less bugs, and it all kind of, it's a path. It's kind of, you're in Rails in that you're like, oh, okay, it makes sense to keep going this way. At least that's my experience so far. I think there's more. I feel there's more.
Right. I mean, Python has some functional parts that has sort of grown over the years, and I've started using that, and it's true that I can sort of make a one-liner that does like a page of C++ in one line. I was just wondering, with a language that is more overtly functional, how that works, and especially in game development. Yeah,
I think going more extreme, like trying to go all the way to the game engine is possible, but it requires a very big mental shift on all your code. And we're all dealing with component-based engines, I guess. I mean, most of us are Unity. I'm using Duality, but it's also component-based. And if we were using XNA before that, and we ended up writing an engine on top of that is component-based. And then when you're doing that, you have a lot of state. So if you're trying to retrofit a functional approach on top of that, it will be quite painful. So the simplest path, and blah, 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 you can see where I'm going with this. It's a thing of like trying to encapsulate your OO kind of outside certain boundary. And then you gain by using functional in certain areas that make sense. And that's my advice so far. Any other questions? Yes.
Well, I would like to know, because you said F# is open source, how many contributors and how many libraries do exist in
libraries are, because the language is actually quite mature, 12, 13 years, there's loads of libraries. And when there isn't libraries native in F#, there's generally wrappers for C# libraries. So that's really good. The interop between C# and F#, it's really, really easy. Particularly when you consume C# from F#, it's really good. From F# to C# is good, but I haven't used it so much. So the things like, I have one problem once, that was but then I used it a lot of times. So my not so good is like I had one problem. And I searched for it online and I found it immediately. So on the libraries, loads. I haven't not found something ever so far. And from the how many contributors to F#, I actually don't know, but it's over 100. Like I know there's like 200 pull requests. So say the most active people are about 50. And Microsoft, they have some money.
And the community, are there people willing to help?
Yes. Yeah. And I actually took, how did I get that desktop? Oh, get out. Okay, thank you. Okay. I actually took this as because I thought maybe someone will ask this. So we're very big on Twitter. And this is F# on Twitter. They're just the hashtag F#. If you have a question, do it as a test about F#. Put it on Twitter and see how long it takes to get a reply. Otherwise, there is the F# chat in Stack Overflow. Or if you ask a question, there's a competition about who answers faster. There really is. This is last night. So the community is huge, and it's very, very welcoming. Like, I told the guys on F# in Paris, hey, I'm going to Paris, anybody wants to meet up? They organized a meetup, stuff happened immediately, super friendly. There's a very nice feeling about it. So I see the community as a huge bonus to working on it, actually.
Okay, thank you.
Oh, and one more thing. There's a few people doing games, but there's a guy that used it on Halo, on the matching algorithm. So it has the credibility in games as well. Not just me. Yay. Anybody else? No?
Would you have used, did you pick F# because it uses the .NET platform? Or would you have did you look at other functional languages? Or?
It's yes, and obviously it was a major thing. It's like, I could just use it. I don't have to integrate it or anything crazy. For example, there's a project now from 2 guys in New York that are using Clojure with Unity. And that's really cool. And I want to look at it, but I am a strongly typed girl, I guess. I like my types, and I know, I hate whatever. Some people like pizza, and it made a lot of sense from the platform point of view, from an actually really nice language, from a great community, libraries. I didn't want it. I wanted to get out of the CLR, but sure. It was just good.
Yeah. Okay.
Yeah.
Any other questions? No? All right, then. Thank you very much.